Hi everyone, I'm Josh Goldberg. I've never asked this question at a group before. Who here has heard of me? 4 people raised their hand. That's why I haven't asked that question. Cool.
That's the wrong question. You should ask who's heard of your work.
Who's heard of Typescript-eslint? Super, thanks. I didn't make it, but I work on it now. Who here has heard of TSLint? I didn't make that thing, but I helped kill it. Aha! That's the predecessor to Typescript-eslint. And I'm talking to you today about linting TypeScript in 2023. I'm very excited about this. Who here lints their code? Y'all better be raising your hands. I'm real disappointed. Murder levels of disappoint in those who didn't. That's okay. Maybe this talk will help you get started. Everything I'm going to talk about is open source. You don't have to follow along. I don't mind if you do. If you're just like this the whole time, that's okay. I assume you're following along. But I've got a template TypeScript repo package, template TypeScript node package repo that this is based off of that sets up like all the linting and auto formatting and stuff for you could ever want. And on this, I'm going to talk about 4 things. I'm going to talk about TypeScript and ESLint. What is this project? Why did so many people raise their hands? I'm going to give you a demo of some of the cool things that the project does for you, some actual bugs in code that it can find for you. I'm going to talk about our next major version. I know major version upgrades and tooling is like the worst thing in the world in JavaScript, and this is okay. And I'm going to implore and enthuse about getting involved. Is everyone excited about this? Yeah. Yay! Cool, thanks. TypeScript and ESLint. Y'all have heard of TypeScript because you're here. Most of you have heard of ESLint. ESLint and TypeScript are on the surface 2 similar tools, but they do very different things on the inside. ESLint sees only the raw syntax of your code. It sees that you have a variable named blah with a value, quote, hello, stuff like that. It doesn't understand the full type system behind that syntax, though. It doesn't understand that if you have a function, that function is supposed to be called with 2 parameters or 2 arguments, and then later in another file, if you call it with 3 arguments to those 2 parameters, that's an error. ESLint just sees what's immediately in front of it, whereas TypeScript builds up a full understanding of everything. Yay, TypeScript. That's really good, though, because ESLint fails at a game that TypeScript wins at. The game is this safe? A game you never want to play for more than a second. You never want to be unsure of, is this code going to work the way it's supposed to? This code here is React or Solid or whatever. You don't need to use any particular front-end framework to understand it. But in general, it's a component, little thing on your page that takes in an action and a children as 2 parameters and an object, and has an onClick and renders a button that when you click, logs, calls the action, logs again. And this is fine code. Like, I have written code like this. Many of us who've done UI things have written code like this. But we don't know, given any usage of this code, whether that usage is safe. We don't know if someone is passing in action and children as 2 props or as 1. We don't know if they're calling it as a function or rendering in JSX. We don't know if action is actually a function in the first place or if it returns async. Given any line of code that references this thing, we don't know unless we have type checking, which is what TypeScript does, a term for any sort of type system like TypeScript that parses your full everything, your project, your inputs, your dependencies, and then creates a type system style understanding of your code. And that's why we have TypeScript-eslint. One of the 2 main reasons why we have TypeScript-eslint. Because TypeScript has an API that TypeScript-eslint uses to inform ESLint of the type system behind your code. And I'll show you later how this actually gets configured, but the main 2 lines here are when you have ESLint running on your code and you want to be able to parse TypeScript syntax, you add in this parser, TypeScript-eslint/parser. And then if you want to start using our rules, you add in at TypeScript-eslint as a plugin, which makes all sorts of super yay useful TypeScript-eslint rules available in your ESLint config. But we don't enable any rules by default for you. That's not how ESLint works. If you want to enable some rules by default, then we generally recommend you use the recommended configs. Just as a curiosity, who here has written ESLint config? None of you. OK, let me show you one. Cool. So an ESLint config looks like this. So it's a JavaScript or JSON file that contains a list of rules for your project. For example, you might turn off a rule by setting it to off, and you might turn on a rule by setting it to warning or error. That says when I run ESLint on my code, I'm going to ask you to yell at me about it. So let's say that you use like the no var rule, which is a rule that says don't use var, use let. And let's say you do like var wat equals true. Now in my file, I have this angry complaint from ESLint with the no var rule saying unexpected variable, use let or const instead. That's a lot of output, but that's how ESLint works. The key thing with configuring ESLint is back in the day, people would have these giant ESLint config files with like hundreds of lines of code, and they would enable and configure every ESLint rule known to humankind, and that's a real pain in the butt. So we have these recommended configs saying ESLint recommended. These are the rules that ESLint recommends you enable. And then in TypeScript ESLint, which is what I'm talking about, the tooling that lets you run ESLint on TypeScript, we have our own set of recommended rules, which in part supersede the ESLint ones. So this is how we recommend you get started linting your code using ESLint. But there's one more thing. I mentioned earlier that this type system is real powerful and important and good for TypeScript code. It's also slow, so we don't enable it by default. So if you want to use the fancy schmancy type system power and stuff in your ESLint rules, we recommend you enable parser options.project, pointing it to your TSConfig, the file that configures your TypeScript settings, and then also enable plugin TypeScript ESLint recommended requiring type checking, the most annoyingly named ESLint config plugin preset in the world, and that enables a bunch of more powerful lint rules. Okay, to actually get some juice going, let's look at a demo. So I've got that linting TypeScript in 2023 thing, that project, and let me just show you it locally. It's a Next.js project. So I just switched to VS Code, ran yarn dev in my terminal, and now it's running this React demo. This React demo has a bunch of buttons. Each button, when clicked, let me zoom in a little bit more, does one action. That action changes the background to a random color and logs or changes text on the screen to that color along with the count of how many times it's been called. Each of these buttons does that. Now, the buttons are intended to be written in a way where you press a button, it waits a second, and then lets you press it again. So it's disabled in that second. But the code is broken. And linting would have shown us how the code is broken. The first lint rule that I want to show is await-tenable. So here's the source code. I'm going to have to zoom out. Source code of the button. And this is basically the same button that I showed in the slides, where we take in an action in children. By the way, this is new. If you look really closely, you can see that the action is highlighted as yellow and children is highlighted as blue. That's because syntax highlighting now is informed by the type system. So action being a function instead of like, I don't know, a number or something means that it's a different color. I thought that was kind of cool. Yeah. It also means syntax highlighting is slower now and takes like a second to load on larger projects, but whatever, trade-offs, software. All right, so action is a function. Children is the type for whatever you want to render, like text or other components in React. Does anyone see the bug? Note that I very quickly said what the bug is, or implied where the bug is, kind of pointed you towards it. The fact that no one, or not everyone just immediately jumped up and said, ha, screw you, I found the bug, is an explanation of why lint rules are really good. Because we don't want to waste our time looking for a bug if we're not even sure that it's there or where it is. Lint rules should just yell at us immediately. The bug, await-tenable, is a lint rule that says you should only await something if that something is a thenable, which is the JavaScript term for anything that has a then method, most commonly a promise. We debated whether we should call the lint rule await promise because no one knows what a thenable is, but technically it's correct as await-tenable. Action is a function that returns void, so there's no need to await it. That's the bug. Now, if I were to go to my ESLint config and re-enable await-tenable, which I disabled for the sake of not giving away what's happening, save the file, now I get this angry yellow squiggly unexpected await of a non-promise, non-tenable value. Thanks, ESLint. And even better, some ESLint rules have a quick fix where you can remove or fix for the code. And then this thing complains, well, another rule is letting us know async hour function on click has no await, so there's no need to make this async, so I'll just refactor. Whoops, didn't need to kill that. And now we see set running true, action, set running false is all synchronous, so there's no need for this running state. So we can kill that. Running is always going to be false, so we can kill that. Disabled equals false, which is the default state for disabled. So we can just kill this. And also these aren't technically the exact same, but whatever. There's no need for this function. I'm just gonna kill it. So there is a debate in the world. Is dead code a bug? What do y'all think? Is dead code a bug?
Yeah.
Yeah. Yeah. Why not? I think it's a bug. And I think it's a bug because it wastes our time as developers, has a small performance impact, and most importantly, makes the code harder to read and work with. So that is a bug found by ESLint. Yay! And just for usefulness, I included links or names in the slides. First rule is await-tenable. The next one is no floating promises, which is my favorite lint rule, both because the name is cute and because it's real useful. And it's kind of the opposite of await-tenable. This button is supposed to wait a second before becoming enabled again, but it doesn't. So if you click it a bunch of times, you get this like nice disco kind of effect going on here. And that's an actual user-facing bug. So if I go to the component here, it's the same props as before, except action now correctly returns a promise, and children is still React Node. And the bug is the opposite. The bug is that action is not awaited. So if we again enable this rule in the ESLint config, we get this handy complaint from Typescript-eslint that promises must be awaited and with a call to catch and with a blah, blah, blah. A few different ways you can await a promise. So that's fixing that little fella. Yay, it's fixed. Cool. One more bug to show you is violate no-misused-promises. This thing crashes. You can see in the code here, I actually got lucky hitting it the first time. If you've been called more than twice, and 50% chance we throw an error. And just to show that again, this has happened. Oh God, the button doesn't even re-enable. This happens when you click the button. Will it fail? Will it fail? Come on. What is the probability we've gotten up to 7? Can someone do the math? There, okay, all right. So in a lot of like Webpack, whatever servers, you get this nice little pop-up saying the unhandled whatever and a stack trace with some nice syntax highlighting. You know what you get in production? Nothing! You get nothing. Or you get whatever nice, UI your developer web platform team set up. But most apps, and I have verified this experimentally, most apps show you nothing because they are not built to handle things like this. So that's a problem. You don't want promises to be floating. You don't want to create a promise and then not have something that handles its dot catch or dot then with the reject. Because sometimes errors happen and you want to give users an actual UI for it, not just nothing. So let's look at the bug. No floating promises. Boop. No misused promises. There we go. So we have a lint rule called no misused promises. And this one is one of our least popular rules because it's real hard to actually work with. Let's re-enable it. No misuse, there it is. Sure, yeah.
For the rules, so you have the ESLint rules and then you also have TypeScript rules. Do you ever run into an issue where like one's overriding or overlapping?
Ooh, great question. Do you ever run into an issue? Restating to confirm I understand. Do you ever run into an issue where there's like a TypeScript ESLint rule that like overrides or funks around with the ESLint one?
Yeah.
Yeah, so constantly, it's real annoying. If you go to typescript-io/rules, we have a whole category of extension rules. Let me zoom in there. So there are a lot of ESLint rules that don't support TypeScript things, but like if you're using TypeScript, you would want them to. For example, a good one is dot notation, which is like the rule that says use like a dot b instead of a array bracket quote b. What we do is we recommend people configure their ESLint configs like this. Turn dot notation, the core one, off, and then turn our thing into warner error. So we just say shove off with the ESLint rules. And in fact, when I enabled ESLint RC, the no var, earlier, you saw an example of that, where I did var white equals true, and you saw, there we go, both the ESLint complaints and the TypeScript ESLint rule complaints.
Yeah, that's what I was, okay.
Good eye. Cool. I also realized I think I'm like slightly offset by 1 in the lint rules I wanted to show, but that's okay. We're spitballing here. We're skip-scabbiting. We're doing. Okay. So let's say that you have a promise and you don't .then or .catch it. It just floats off into the ether, which is what you saw in that demo when there was an unhandled, where is it, this thing. So that's bad, which is why you always want to await your actions. But what happens if you create a function that is async and then pass that async function as a parameter, as an argument, to a function or a location that doesn't expect it to be an async function? What if you pass an async on click to a property on click that doesn't know whether it's going to return a promise or something else? So await or no misused promises is the last rule I'm going to show, which is the same code as before. It's an action that returns a promise, a function that, and it properly awaits the action. But in my pages index TSX, I throw an error half the time, let's say. So that means that action can throw. And it is a true statement that in programming, almost anything can throw at any time. You never know when something's going to throw like an out of bounds error or some function's going to randomly run out of memory or something. So for async functions specifically, because they create promises that are async and have weird call stack intricacies, we recommend doing something like this. You create a run safely function that's used everywhere in your code that takes in an action and what to do on error. And then the body of that function is just returning a function that calls the action with .catch on error. And then the way you might use that is your onClick is now run safely, async, call set running true, action, set running false. And then if there is an error, then set error, set running false. So what I have in code, what I have in the demo is this may fail safely does that, and whenever, first try, whenever an error is thrown, it's caught nicely and logged, and then we still set the disabled state to no longer disabled. Anyway, that's all the demo stuff I wanted to show. I think I got my slides offset by 1, but that's okay. There are a lot of cool things you can catch with linting, a lot of bugs, a lot of stylistic inconsistencies you want to nail down in your app. So highly recommend, if you haven't checked us out, just enable the recommended rule sets, go through our linting docs, and see what you get from there. Some stuff that's coming up, by the way, we've got an upgrade blog post. If you're interested, you can check it out on GitHub. It's number 6515, linked there. If you really want to get wild, you can try TypeScript ESLint v6 in your own projects just by doing this. Please do. Please give us feedback. That'd be great. But a few things that we're changing is, for one, I did not like how I had to skippity-doo off to the side here to say that whole config name. So we're simplifying the config name, yes, to just recommended type checked. And we're splitting out all the stylistic recommended rules into their own config. So all of you screaming at us about how you prefer your arrays with the like generic syntax instead of the array syntax or whatever crap you're doing, you don't have to yell at us anymore. You can just not use our stylistic preset. Also, and this was a surprising amount of work, we're making it so you can just say true to find the closest TSConfig to every source file. Most projects use /tsconfig.json, but if you're like in a mono repo or something and you have a lot of TSConfigs, specifying an array of them in the right order can be annoying. So just project true. Good. Definitely recommend trying out recommended type checked because we also like updated a bunch of stuff. And also definitely recommend stylistic to see if your stylistic preferences match ours. If they don't, you're wrong. Just kidding, everything is valid. And then project true is like actually a performance consideration because we have to resolve to the file system every time we lint a file. So please try it out and let us know if your linting becomes shockingly slow. We have caching, who knows if it works. All right. So if you're curious about all the changes to the configs, like the recommended rules, what we now enable or reconfigure or disable, definitely please check out the changes to configurations for 6.0.0 blog post. Pardon me, GitHub discussion, not yet a blog post. I'll show you it now. Nope. PowerPoint. It's this huge table of all this stuff, all the changes that we wanted to do. Oh, that was like 2 weeks ago. Whoops. All the things with like little annotations of like why we no longer disable it. I use the poop emoji for layout related lint rules for important reasons. So definitely check this out. Here we go, current slide. We also have a milestone if you want to get involved with the project. If any of you are curious about ASTs, definitely would love your help. This is pretty much out of date. We're now 82% complete as of this morning, not to brag or anything. So I just got back from a trip to Hawaii, which was great, and I'm a little delayed, but this week I'm going to start sharing these things out and yelling at people on Twitter and Mastodon and such. So please join up. Anyway, if you do want to get involved, we have over 350, I believe, open issues that are ready, willing, and able to be looked at by you, many of which are labeled as good first issue. So I would love, this is me asking you politely, begging, please, we need more people getting involved in the project. TypeScript ESLint is important. Linting code is important. Finding bugs the easy way rather than the hard way is important. And we have been trying very hard over the last year and a half to make it so it's as easy as possible for someone who's never touched linting or is scared by the word AST to get involved. We also have this cool React website, typescript-eslint.io/play is a playground on the site. So if you don't care about linting and if you just want to work on React, fine. So I really want you to contribute. If there's anything I can do to make it easier for you to contribute, please let me know. You can DM me on Twitter or Mastodon, except you can't really DM on Mastodon. It's like a private tweet or whatever, a toot, but email works too. So let's recap. TypeScript and ESLint love each other. I showed you a demo. We have a V6 coming out soon, and I'd love you to get involved. About me, I'm Josh Goldberg. I maintain TypeScript ESLint and some other stuff with other people. I also wrote a book, Learning TypeScript, which you should definitely buy. Who here has my book? 2 people, thank you. That's not enough. Shame on you all. Also, I'm a full-time open source person. I don't have a job. I don't have my own health insurance. I pig off my wife's. And I do this because I really care about it and think it's important. So if you want to sponsor me on GitHub, that would be cool, and it would let me work on more shared open source tooling that you all, literally all of you, use. Unless you're not a developer, in which case you might use my stuff, I don't know. Specifically, TypeScript ESLint. We actually have a new logo. I forgot to update this slide. But we have an open collective if you want to sponsor us. Fun fact, we're also the reason why Prettier can work on TypeScript code. So if you use Prettier, who uses, yay! Oh my God. Cool. Well, thank you very much. Yay!
What's your most controversial stylistic rule?
What's our most controversial stylistic rule? Types versus interfaces. Who here has heard of the great debate of types versus interfaces? Who here wants to get into that right now? You're wrong. We're not getting. Yeah, so it's basically a stylistic preference now using like type X equals object thing versus interface X. But there are like subtle nuances of like when one is important and necessary versus the other. I think that for a while we had it enabled to prefer interface. I don't remember whether we did. It's been a while. Yeah.
So something gives the perception that you really care about typing. Something. Do you think that there are any arguments against typing that you sort of agree with?
Any arguments against? Oh yeah, for sure. Against typing. So I normally go by give or take a rule of 3 of when to use TypeScript or an equivalent for your JavaScript. These days there is no other equivalent, so just TypeScript. Take that flow. If you have 3 or more developers, if you have 3 or more files, you should probably use TypeScript. Probably. But if you as a person or you as a dev team, individually / collectively, don't know TypeScript and you're on a tight deadline, onboarding this new thing with very obscure error messages at times that complicates your dev flow might not be a good idea. TypeScript's advantages are fantastic and wonderful, but there are cons. And the cons are often that it's harder to use if you don't know it yet. It takes time to ramp up on, and it adds complication to your build processes. People also add in new cons when they misconfigure it, like making it take longer to build locally for dev previews, which should never be blocked on type system complaints, but you never know. So yeah, I think after 3 developers and 3 files, unless you have a bad situation, like being in a constant rush and having bad management priorities, you really should use TypeScript though.
Thanks.
Good questions.
So with the O'Reilly book, I appreciate carrying forward the animal tradition. Just curious, did you get an input on that, or did they assign you an animal?
I get asked this a lot, actually. It's a question I had coming in. I gave input. I don't know how much the input was received. I wanted a bird. Specifically, I wanted a parakeet because I grew up with a really cute budgie, and they gave me a sun conure. I'll take it. I was worried it'd be like a crab or something from the recipe. That's the exact premise of the game. You run around and you're a goose and there's a honk button and you can honk at people. That's not what I'm here to talk about.